Hello friends, in the first two videos we have seen how to draw the polar plot and then we solved two numerical examples and drawn the polar plot for the given systems, and then also we determined the phase crossover frequency, then y-intercept, x-intercept, gain margin. Now all those examples were minimum phase examples where all the poles and zeros were in the left half of S-plane. In this class we will see two typical examples where either a pole or a zero is in the right half of S-plane, and then how the polar plot takes a different shape. Let us take one example. Example as, let us take sketch polar plot of g of s equal to 1 minus 2s upon s into 1 plus 2s. In this example you can see this is the right half pole 0. This 0 is in the right half of S plane. This is not in the left half of S plane. If you draw the pole 0 plot for this, here is one pole at origin. This 1 plus 2s equal to 0. So s is equal to minus 1 by 2 and 0 is here in the right half of S plane. So in this case the phase angle will change. Let us see how. So if we want to start solving this numerical example, then we will follow the simple steps. First step is from g of s get g of j omega. 1 minus 2 j omega upon j omega into 1 plus 2 j omega. Then its magnitude. Magnitude function is here under root real part square, that is 1, plus imaginary part square. Now what is imaginary part here? Minus 2 omega. So its square is 4 omega square divided by. What is magnitude of omega? J omega is omega. And for this real part square 1 plus imaginary part is 2 omega, so 4 omega square. So this gets cancelled and then magnitude is 1 by omega. Here it gets cancelled because both are having 2 j omega term. If the terms are different, then it will not cancel. It will take its own values. Then angle of j omega for the numerator, this is 1 minus 2 j omega. Then what is its phase? Its phase is 180 minus tan inverse of 2 omega. Let us see how it is done. If you have a number x plus jy, then its magnitude x plus jy is under root x square plus y square, and angle of x plus jy is tan inverse of y by x. Then what about x minus jy? X minus jy has same magnitude as x square, x plus jy, and x minus jy has same magnitudes. Why? Because square of negative number becomes positive. So this is again under root x square plus y square. But this phase is 180 minus tan inverse of imaginary by real. So this is the difference. The phase is different. So same thing will be applied here. So for this it is 180 degree minus tan inverse of omega, then minus in the bracket addition of phase of this. So phase of j omega is 90 degree and phase of this is plus tan inverse of 2 omega. So this is the phase of tan inverse of 2 omega of this, and then it is nothing but 180 minus tan inverse 2 omega minus 90. So 180 minus 90 is 90 degree minus 2 tan inverse 2 omega. So this is the phase. So be careful while finding out the phase angle when there is either a zero or a pole in the right half of S plane. So in this example we have taken 0 in the right half. In the next example we will take pole in the right half. And now we have done this, then for different frequencies, that is 0 and infinity, we will find out its magnitude and phase. So I will recall. See, this is step 1. Lecture number 1 you can see. Then this is step 3. So when I put here 0, this becomes infinity. 1 by omega is magnitude. If I put here 0, it becomes infinity. And when I put here infinity, it becomes 0. And now about phase. When I put here 0, so tan inverse 0 is 0. So 90 minus 0 is 90 degree. And when I put it infinity here, so tan inverse of infinity is what? 90 degree. So 2 into 90 is 180. 90 minus 180 is minus 90 degree. See. So here in this case, how will be the plot? How will be the plot? That is step 4. Let us see. Polar plot. Step 4. This is real. This is imaginary. So at 0 frequency, magnitude is infinity, angle is 90. So angle plus 90 means here. This is plus 90. So it is here, this point. And it is coming to minus 90. Means it is coming to minus 90 while crossing 0. While crossing 0 like this. It is coming to minus 90. So this is the point where omega is equal to infinity, and this is the point where omega is equal to 0. So direction in this case. This is the polar of this given example. See, step 1, S converted to j omega. Step 2, obtain magnitude and phase functions. Step 3, obtain values of these two at omega equal to 0 and infinity. And using these values, we draw the polar plot. How? See, initially magnitude is infinity, angle is 90 degree. So this is 90 degree and it is infinity, somewhere above. And then see, magnitude is decreasing. And while decreasing, angle is increasing from 90 to minus 90 through 0. See, it is coming here, magnitude is decreasing, through 0 it is moving to minus 90 where angle is magnitude is 0. So this is the polar plot of this particular example. So I hope you understood this. Let us take another example. Now in this case, what we will do, we will sketch the polar plot of the example. Here I will take 1 plus 2s in the numerator, and in the denominator it is s plus 1 and 1 minus 2s. So this is another example. So in this case, again step 1 is same. 1 plus j2 omega or 2j omega, it is same. Then this is j omega plus 1 into 1 minus j2 omega. Step 1 is over. In step 2, we will find out magnitude. So magnitude of 1 plus 2j omega is under root real part square plus imaginary part square. Imaginary part is 2 omega. Upon magnitude of this is what? Real part square plus imaginary part square. Again here real part square plus imaginary part square. So this gets cancelled and this is 1 upon under root 1 plus omega square. Then angle. Now for angle, if we take the numerator, the angle of numerator is tan inverse of imaginary by real is 1. So tan inverse of omega minus angle of the denominator. So that is tan inverse of omega, angle of this. Now this. Let us recall the previous example. Here you have negative sign. So it is plus 180 degree minus tan inverse of imaginary by real. And then it becomes tan inverse of 2 omega minus tan inverse of omega minus 180 degree minus plus becomes tan inverse of 2 omega. So it is minus 180 degree minus tan inverse of omega plus 2 tan inverse of 2 omega. So this is the angle we got, and then in step 3 we get omega 0, infinity, and magnitude and phase. So this is the step 3. So this was the step 1. Then this is the step 2. Then this is the step 3. I put here omega equal to 0. So this is 0. If I put here 0, root 1 is 1. 1 by 1 is 1. And now I put here infinity. Then this is 1 by infinity is 0. Now let us see the angles. At omega equal to 0, it is minus 180, minus 0, plus 0. So it is minus 180. And when I put infinity, this is minus 180. This tan inverse infinity is minus 90. So minus 180 minus 90. See, I get it here. Minus 180 minus 90 plus 2 times tan inverse of infinity is 90. So plus 180. So this is minus 90 degree. So minus 90 degree. And then let us check. Draw the polar plot. See, initially at omega equal to 0, magnitude is 1, angle is minus 180. So angle minus 180 is here, and this is 1. This point is 1, angle minus 180. Then magnitude is moving towards 0, and angle is minus 90. So it is going to minus 90. This is omega equal to 0. This is omega equal to infinity. Very simple. It looks simple, very short problem, but students are making mistakes in finding the phase of this because of this negative number. So purposely I took these examples, 2 examples, which are typical and called as non-minimum phase systems. So thank you. I hope now within the 3 videos I have covered the polar plot entirely. Hope I get a chance to make another video to cover nitrous plot. Thank you.